Hello and welcome. For this video we are looking at nuclear fusion, and we have in the past looked at a process called nuclear fission, and nuclear fission is where we have a large nucleus which is split. So fission is the splitting of a nucleus, or we split a nucleus to release energy, and that energy was used to generate heat in a power station. Now for nuclear fusion the process is slightly different. It does involve the level of the nucleus of atoms, so we are talking about nuclei of atoms, but the process is slightly different. With nuclear fusion we have the nucleus of one atom joining with the nucleus of another atom. They have to be quite small nuclei, but fusion is a process when these two fuse or join together, and when they fuse or join together a rather large amount of energy is released. So that energy could potentially be used to generate heat for a power station, similarly to nuclear fission. Now the problem with this process is that the nucleus of each atom has a positive charge. As you know, the nucleus is made of protons which are positive and neutrons which actually have zero charge. So overall the nucleus will have a positive charge, and if you try and bring these two together, the two positive charges will quite strongly repel each other, so it's very hard to get those two to fuse together. If we could get them to fuse together, we could release that energy, and that energy would be very useful for generating electricity. Now this process does actually happen naturally, but it happens in the center of stars. So here I've got an example of a star. In actual fact it's our sun, and our sun, at the core of it, at the center of the sun, it is roughly 75% hydrogen and about 25% helium, which is another element. Now if we were to look a bit more closely, we could remove a couple of the hydrogen nuclei. Let's enlarge those a little bit, and as shown in the previous example, these two both have a positive charge. We have one proton and one neutron, that gives them both a positive charge. Now bringing them together, as we said, it can be quite difficult because they tend to push each other away. The key thing about the center of the star though is that there are a couple of conditions that allow these two to be joined together, and the first one is that there is a lot of heat, and the second one is that there is a lot of gravity. And when you put these two together, it means that there is enough energy in these two nuclei for them to be able to join and fuse together and release some of that energy. So joining these together, fusing them together, will actually cause the production of a new nucleus and the release of energy. Now we started off with hydrogen. In this example it was hydrogen with one proton and a mass number of 2, and the new nucleus that we have is now helium, and helium has a proton number of 2 and a mass number of 4. It's probably worth mentioning that there are other isotopes of hydrogen that can be found. This one has 2 neutrons and 1 proton. The important thing is it has 1 proton, so it is still hydrogen. It just happens to have a slightly larger mass because it has 2 protons, but in a similar way these can also collide to carry out nuclear fusion and release that energy. So this is a process that happens naturally at the center of stars, our sun being an example of one, and scientists have been quite interested in this process because if we could get 2 hydrogen nuclei to fuse and form helium nuclei here on Earth, we could harness all that energy and we could use it to produce electricity in power stations. One of the advantages of that would be that the production of helium, which is non-toxic or non-radioactive, this would be a much better byproduct than we currently have with nuclear fission. So a basic summary of the two processes is that nuclear fusion is the fusion or the joining of 2 nuclei to form a slightly larger nuclei and release energy, whereas nuclear fission, you would split a nucleus, release some neutrons and some energy, and this is used in a nuclear reactor currently, as we've described before. But just going through a couple more comparisons, we've got the joining of small nuclei and energy is released. We have no radioactive waste products. As we said, it's helium that's produced, and that's fairly safe, very safe in fact. But the only problem is it's not achieved at low temperatures. Scientists are trying very hard to recreate this on Earth. At the moment it hasn't been possible to make it go on for more than a few minutes at a time. But if this process is cracked, if we can actually make this happen in nuclear fusion reactors, we can provide lots of very cheap and safe energy that doesn't produce any waste or radioactive waste or any dangerous byproducts. With nuclear fission, however, we have the splitting of large atomic nuclei, energy is released. Similarly to fusion, in that energy is released, we have radioactive waste produced. So when the fuel rods are finished with, they are radioactive for a very, very long time, and they have to be kept safe for a very long time. And the last thing is, we do have the technology developed and it is in use. So here's a couple of comparisons for nuclear fusion and nuclear fission. Make sure you don't get those two mixed up, because although they are to do with radiation, radioactivity, the processes are slightly different, and you need to know how they are different. So that's about all I wanted to go through for this video. That's me done for now. Thanks for watching, and I'll see you again soon.